we move on to the main content, I would like to give a very short intro of the two companies, BitGreat and LeWagon, who are behind this event. And I will probably start from my side. Please allow me to share my screen. Okay, cool. As I mentioned before, my name is Sasha. I am working at LeWagon Tokyo. And what is LeWagon? It's a global coding bootcamp. In other words, it's a very intensive programming school where we teach people web development and data science in two formats. For those who want to dive into the world of tech right now, we offer 9-week full-time course. And for those who have some family or work commitments, we offer 24-week part-time program. A bit stats about LeWagon that we are proud to show off. We are top-ranked bootcamp worldwide. And we started 6 years ago in Paris, France. Since that time, we hit over 10,000 students who went through our boot camps in 40 cities around the world. And we are very product-oriented boot camp. We don't teach theory. We teach people how to code and build products. And that's what our students do during and after the boot camp. And also that's the reason why so many startups being born out of our boot camps. A bit about what data science bootcamp, since a lot of people who gathered here obviously have interest in data science. During our data science program, we teach a lot of skills necessary to kick off your career in data science, starting from the data science toolkit and ending with the data engineering. And the last 2 weeks are project weeks where our students build data science projects based on the data sets they get from companies or competitions like Kaggle or maybe BitGreat in the future. I hope so. And one of the course outcomes that what kind of career paths where students usually choose after the data science bootcamp, they can become junior data scientist, junior data analyst, junior data engineer, and data strategist. And about our Japanese campus, we are located 7 minutes walk from Meguro. Right now, we are delivering our bootcamp programs in a hybrid format, means for those who want to study remote can do it remote. Those who want to come into campus, feel free. We teach in English. It means that's why we have a very diverse group every time from 7 to 14 nationalities participate. And that's going to be a last slide from me. For those who are interested in our data science programs, feel free to reach out to me. Our part-time program starts February 20th and the full-time starts on April. Cool. And right now I stop sharing my screen and I give the microphone to Yuria.
Hi guys, can you hear me? Hello.
Yes.
Oh, thank you. Let me share the screen. Can you see the screen now?
Yep.
All right. Thanks, Sasha, for the introduction. My name is Yuria from BitGreat. Like, we are located in Nakameguro, Tokyo, Japan. I'm sure like you probably may heard of like our project already, but I'll just kind of like introduce our project and the company just briefly, like for those who you don't know yet. So BitGreat is an AI competition platform, and we also have a job board function recently. We are operating like as of now for like three different offices starting from Japan, India, and Estonia. And we formulate like 25,000 data scientists in the community. And as of now, like we have about like 35 employees of different countries. And we are developing like this ecosystem for AI engineers, data scientists, and also data analysts. So it's been almost 3 years now since we actually operate this companies. And as of now, we have the online competition platform, which you might have already joined. Thanks for like those who actually joined already. So it's a free AI competitions. You can just sign up, register on a platform, and then you can just go to the open challenges, which is for the video population popularity prediction challenge as of now. But it's a real world problems, you know, like from those companies like who are actually looking for the solutions. We actually support them. And especially like for the winners who actually win the competitions, we will actually compensate them like from the prize money from the client. At the same time, you will also have the leaderboard featured. Like on the leaderboard, you will see like who is actually like getting the like how much is the scores. Like when you actually join the competition, you will see like your own scores as well as the leader, like prize money and everything. So for the hands-on experience, like you can actually put like on your CVs or resumes, like which is your score, like etc. And also it's the like we have a lot of different industries for the competition, so you will see like a lot of different challenges. At the same time, we have another feature. It is a job board function. So you will see all the different open job positions, and at the same time, you will see like a lot of different skill sets. Based on your own skill set, you can also apply for the jobs, which we are actually opening like for a few different positions as of now. And mostly like it is located in Japan at the moment, but we will also like expand the market quite soon. So yeah, like for the new competitions, I will send you the link later on the comment section. But like there is a new challenge. It is for the predicting the different views on each video, which is quite interesting. I think you will probably see like on bakery.net. And if you have any questions, reach out to me like by comment or just go to info@bakery.net. You can just send me any email. We will probably like see you soon later. Thank you so much.
Cool. Thank you so much, Yuria, for your introduction. And now we will move on to the main content of the topic. And before that, so you guys probably, when you access the event description, you read that the challenge that we'll be talking today is called Swipe to Success. And I'm here having Jorge from BitGrid, who will explain more about what kind of challenge was there and gives an overview of it. Jorge, please go ahead.
Thank you, Sasha. Let me just share my screen now. Okay. Can you guys see and hear? Yep. Okay, so, well, hello everyone. Thanks for joining today's webinar. My name is Jorge. I am a data scientist at BitGrid. I'll just share with you a brief overview of the Swipe to Success competition. So this competition was sponsored by a Japanese company called Attrae, who are the creators of an app called Yenta. And what is Yenta? So Yenta is a professional matching app. It's basically like Tinder, but for business and professional relationships. It is quite a big app in Japan. They're doing very well. They just recently launched in India. So to give an example of how it works, let's say I have a business idea and I am a developer, but I need someone with a business background to actually sell my idea or work more on the sales side. So I can use Yenta to look for someone with that background that is in turn looking for a developer like me. So Yenta's recommendation algorithm shows me 10 profiles every day based on my profile and using the recommendation algorithm that they have. And I can either swipe right if I am interested or swipe left if I'm not interested. And if we match, which means that I am interested and the other person also interested in me, then we can arrange a meeting and to discuss potential business opportunities. And after we meet, I can leave a review of the other person, and I will be reviewed by the other person too, ideally. And well, of course, if things go very well, you can establish a business relationship or even start a new project or company or something like that. So okay, so what is the goal of this competition? So the goal was to improve. Oh, sorry. So I think the goal was to improve this recommendation algorithm. using AI, right? So more concretely, what we wanted to do is predict the level of compatibility between given two users. So let's say I have two users, call them user A and user B. We want to predict how compatible are these two users as one of these four classes. So class 0 will be user A and user B will not match. So class 1 will be user A and user B will match. Class 2 will be user A and B will match and meet, but user A will leave a bad review of user B. And finally, class 3 will be user A will match and meet. User A and user B will match and meet, and user A will leave a good review of user B. Okay, so how does the data look like? So this data is a subset of all the Yenta data. Of course, this is not all the data of the app, but we try to use most of what could potentially be helpful to increase to build up recommendation algorithm. So naturally, we have user data like age, biography, school, works, stuff like that. But we also have interaction data. So yeah, user data includes anything from your schools that they attended, work history, skills, stuff like that. And we have users interaction data, which includes information related to pairs of users. So for example, swipes, you have, for example, data on if user A was interested in user B. You have reviews. For example, what was user A's opinion of user B after they met? Stuff like that. Of course, the data that we provide for training here is not the same that we use for the evaluation, because that's what we want to predict. But this data could be used in many ways for training. So in case you wonder how is this data public, well, it's not really public. This data is, of course, anonymized to protect users' privacy. So for example, instead of using school names, we had school IDs that only Yenta knows how to interpret. Same thing with companies and work IDs. So each company name is mapped to a particular ID. Same thing with skills. For example, you could say the data science skill would be number 14 or something. Other things like age can stay the same, since anyway the user ID is already anonymous. So yeah, and also we had some text columns on our data, like biography or review messages, comments. So that was vectorized using text vectorization algorithms. Specifically, we chose 300 dimensions to represent this text data for this time. Okay, so to give a more concrete example on how you could use the data, we could arrive to an input of like this sort. So let's say we have a pair of user IDs from our training set. So we could take all the attributes that we are going to use. For example, age, strength of their skills, the self-introduction dimensions, and we merge together this using these user IDs and group them together into one vector for each user. Then we can concatenate these two users, which each user would be a long array of many numbers, which in turn are these different attributes of these users. And finally, our target value would be just the score between these two users. So in this example here, we can see that the Y value is 1. So that means that they matched, right? So once we convert all of our examples into this shape, we can train our model, which can be anything, from gradient boosting algorithms, neural networks, or whatever you choose. And we can train our model so that we are able to make predictions on the test data that we had provided. So yeah, so that's how the competition was, structured. And after 2 months, so participants use this data in many interesting and creative ways, way more creative than we thought they could, use. And after 2 intense months of working, we ended up with these final top standings. So all these participants won a prize, being Nikhil Mishra, the first place with the grand prize of $5,000. So yeah, that's about it. So today, Nikhil himself will be answering some questions from the community to talk about how he approached this particular challenge. So yes, without further ado, thank you, Sasha.
Thank you so much, Jorge. Finally, we will move to the final, the main content. But before that, just a quick question to the BitCrit team. Do you guys know how many people actually participated in the competition?
Yeah.
Maybe the question to you.
So like after actually like 2 months, like we had about like 1697 participants in total, and we also had the 996 total submission files.
Well, that's a lot. So obviously, Michiel, that's a lot of questions maybe people would like to ask to you today. How were you able to, overcome so many competitors on your way and come with the best solution? Thank you guys one more time. And for those of you who are joining us tonight, I strongly encourage you guys to write your questions to Nihil, our winner today, in the chat. Of course, we have some questions already prepared, but it would be really cool if you guys have any additional thing that you would like to clarify on something that you might be interested in. So feel free to shoot your message in the chat. We will definitely ask it to Nihil. And finally, we are moving to the talk with Nihil. Nihil, so sorry that it took us so much time talking about ourselves, and now that's time to talk about you. First of all, can you please introduce yourself?
Yeah. Thank you, Sasha, Yuria, Gore, and the entire Bedkit team for giving me this opportunity. So currently, I'm working as a data scientist in a company called Kama Life in Bangalore. So I just completed my bachelor graduation this year itself and joined the company. So basically, if we talk about my journey in data science, I started data science 3 years ago. And from the time I started data science, I started participating in competitions because I felt that competitions always give you something new to work on, some real life problem to work on. So it builds up your data science skills a lot. So yeah. Uh, so after 2 to 3 years, I can see the results of my hard work where I'm regularly winning competitions, including this one. So
Cool.
yeah, thank you.
So you said you're just graduated from bachelor studies, is it correct?
Yes, yes.
What is, if it's not secret, what is your major?
My majors was in computer science itself.
Okay. So, and right now you're working as a data scientist, or what are you doing right now?
I'm working as a data scientist in a startup in Bangalore in India.
Cool. So what motivated actually you to start joining these competitions? Because I've heard many reasons people join competitions. Some of them want to find a job actually as a data scientist based on their high score. Some just want to practice their skills. Some just want to obviously win some money. What was your main reasons that prompted you to start participating?
Yes. Talking about this competition, one motivation was definitely the money. So the money was a lot here. And apart from it, yeah, I wanted I always want to challenge myself with a new problem. And when I was searching through the machine learning competitions that were going on, I found this competition really interesting. So I could relate it to a kind of problem that I'd been solving earlier. Or say this battery app is similar to say Tinder. So say I've seen the Tinder app, I've seen people using it. So I thought I can, use my experience of, say, knowing about the app in this competition itself. So my motivations would be definitely the money. Uh, then obviously solving a real life problem. And if you participate in a competition and do well, it definitely helps in your job search and adds something to your resume. So yeah, these are my motivating factors.
Cool. Is it the highest result you ever got in the competition?
In terms of no, in terms of prize money, yes, but uh, I guess I've finished top 3 in over 30 plus machine learning competitions till now. So, but in terms of prize money, yes, this is definitely the biggest I got so far. So this competition is special for me.
Cool. And also heard that many data scientists prefer to work in teams in order to win for data science competitions. Do you usually work alone, or you sometimes team up with some people?
I love to actually team up with people, right? So when you team up with people, you actually build a lot of connections, and uh, you work with ideas that are not your own, right? So when you come across a variety of ideas, that actually sharpens your skills. So currently, too, I'm working in a data science competition with some team members. I'm actually working in 2 to 3 data science competitions with team members. So I love to work in teams, but yeah, this competition was solo. So I wanted to win it as a solo competitor.
All money for yourself, okay? Noted. Cool. So we move on with the questions. Once again, for those who are listening to this talk, guys, feel free to shoot your questions in the chat. Do you have any domain knowledge or experience in similar industries?
If you talk about my domain knowledge, so my domain knowledge will come from the experience that I get from participating in competition. So say um, if we just talk about this competition, so I did not have much experience about this kind of problem, but yes, I knew that there's a similar app called such as Tinder, which does a similar thing. So I tried to use this knowledge, and whenever I start a competition, I spend some time researching about the problem statement. So what are the existing solutions? How have people in the industry solved this kind of problem before? So that gives me a good amount of domain knowledge to proceed with any problem.
Oh, are there many matchmaking applications in India?
Yes, I guess there are a few, and many startups are actually now making even more matchmaking applications in India. So I guess you'll find quite a few.
Cool, cool. Thank you. Okay, so probably I already asked did I ask the question? How did you first find out about this BitGrid competition?
Okay, yeah. So I think I found it on LinkedIn. So one of my friends had tagged me for this competition. So jokingly, I told him that I'll win this competition, and then 3 months later, I actually won it, and I feel happy.
Cool, thank you. And some people in the chat demanded we move on to the technical part. Definitely, we just wanted guys to give you some background to understand the Nikhil's background before moving on. And Nikhil, so the question is, can you share the summary of your solutions to the competition challenge?
Sure. So should I start sharing my screen?
Sure, go ahead.
Okay, fine. I hope you guys can see my screen right now.
Yep.
Okay. Okay, fine. Just a second. Okay, so the competition goal was already talked about by Gaurav. So I'll move on to the summary of my solution. So what platform did I use? I use I use Google Colab Pro for building my solution. So in Google Colab Pro, you'll get 40 cores plus around 36 GB RAM. So basically the data for this competition was quite huge. So you need some good machines. So you can go with say AWS or Google Cloud or other cloud-based solutions. Or if you have a good machine on your own, that's great. So for me, I use Google Colab. What languages did I use? I used Python. And what major libraries I used? So I use say pandas, NumPy obviously for data analysis, and then joblib and pandarel for faster processing and feature creation steps, and a light GVM for my modeling part. So yeah, how many features did I use? I used 330 features. What was my validation strategy? It was stratified k-fold. And what was my validation accuracy? It was around 86.9. My final model was an ensemble of 6 to 7 different models. And my single k-fold model runtime is 2 to 3 hours. So basically 2 to 3 hours is an, is the total runtime for say a 5-fold model. So it's basically the total runtime for 5 models. So I'll quickly summarize my solution. So if you guys have any doubt, you can ask me in the end. Okay. So what is the general approach that I follow for any machine learning competition? Okay. So firstly, I understand the problem. If I don't have the domain knowledge, I research about the domain knowledge. Then I'll try to understand the data. Then I'll simply build a quick solution. That's the baseline. Okay. Then I'll try to analyze the data, create some good features out of it. Then I'll finally build a validation strategy, build some kind of modeling, and then I'll analyze my results. Okay. And then I'll go back to step 4 and we'll repeat the step 4, 5, 6, and 7 till I get a considerably good solution. Okay. And then finally I'll build an ensemble. Okay. So now we'll talk about thinking about the problem. So what kind of problem is it? It's a matching problem, right? So we have all seen matchmaking apps. Some of us probably have used matchmaking apps, right? So how do we actually find matches, or how do we think two users are compatible? So one way to measure compatibility could be to find the similarity between the two users. Or instead of similarity, if you want, we can uh, talk about the dissimilarity between the two users, right? Okay. If you guys have any questions, I see a lot of questions in the chat section. So I'll come to the questions at the end. Okay. Yeah. Now I'll talk about a simple thought process. So if some of you guys have already solved the problem, you'll understand this part much better. If not, try to follow along, you'll get some part of it, okay? Now, given the data, we had very simple features such as for any two users, we had the ages of the two users. Say it can be age user A and age user B, right? Now, what's a simple feature that I can create from it? The age difference between two users. Now, say, why would I want to create such a feature? Because I would say that I would most probably match with someone who's near my age, right? So, say if I am 22 years of age, I'd match with someone in the age range of say 20 to 25, right? That makes sense. Now, if we think about say some more complex feature, what can we do? What's the average age of the people that the users have matched with, right? So say I'm matching with users of age, say 22, 25, 27, 28. So my average age is around say 24, right? And say the other person is matching with people of age, say 30, 35, 36, 37, right? So maybe he's looking for more experienced people, right? Now, what more complex feature can I create from it? I can find the difference between the above two features, or say mean ages of dates of user A versus mean ages of dates of user B. Okay. And what's an even more complex feature that I can create out of it? It is the difference between the ages of user and the average age of the users he or she has dealt with, right? So basically in any machine learning competition, what I'll do is I'll start with very simple features, and then using say some data analysis or some domain knowledge, I'll try to create more and more complex features. Okay. Right. Now there was also interaction data, right? So for the interaction data, I'll again take a simple example, that is interaction swipes. So interaction swipes is basically the historical data of any given user, right? So we'll have historical data for two users, in each sample of the data that we have, right? So what is one simple question that we can ask from this? We can ask how many users has user A interacted with in the past? How many users has user B interacted with in the past, right? Then what's a little more complex question that we can ask from the data? Uh, how many users has user A been interested in? How many users has user B been interested in, right? Now, let's go a bit more complex. So we can now find the ratio of the number of users A was interested in versus the number of users B was interested in, right? And we can also find the same mean. So how many users was user A interested in divided by the number of users user A interacted with, right? So basically, even if you don't get what I'm saying right now, the idea is to go from very simple features and create more and more complex features, right? So you don't have to create, say, the most complex of features all at once. So you should improve gradually and iteratively. So that's the base here. Okay. Now, yeah, before going to the tips for future machine learning competitions, I'll take some questions. Okay.
Yeah, we have a couple of questions in the
Okay.
chat. So if it's possible to go to the slide with approach, we have two questions about the slide with for your approach.
Yeah, sure, sure.
Yeah.
Okay. So, so Saji has a yeah. So Saji has a question. So what's the criteria for steps 5 and 6? Okay. So as I was explaining, so how do you create good features? To create good features, firstly, you need to say understand the data. So what my data is about. So this data is about matchmaking. So how do I create features that capture the similarity between two users, as I talked about in the next slides, right? And then to create good features, firstly, you must start with very simple features and then move on to say more and more complex features. So if you start with very complex features in the beginning itself, then most of the time your code ends up in a mess, okay? Now, how do you build an ensemble? So building an ensemble is a topic that obviously cannot be covered in this session itself, but the idea is to build a variety of models, right? So if you build a variety of models, then when you combine them, the net result is better than a single model alone, right? So basically, say you build 5 models with different feature sets, and then when you combine them, the final result that you will get, it's better than the individual models, okay? I'll share my presentation at the end, so don't worry. Okay. Okay, Michael has a question. So, okay. So, yeah, for those of you guys who don't know, Michael had teamed up with me in the past, right? So he had teamed up with me in a different competition, and he's been a great competitor. So, yeah. So his question is, do you also try approaches to generate a lot of features by interactions between the features, even if the link between them is not intuitive? Right. So firstly, Michael, I would try to generate features that are intuitive, right? So features that I can understand from the domain knowledge. Now coming to the features that are not intuitive, that we have to generate by, say, some kind of data analysis. Now, say if two features are, say, positively affecting the target, so in that case, I would try to link them with some kind of interaction, right? So if the link is not intuitive for any feature sets, what I would try to do is basically uh, try to do some kind of analysis that by which I can relate the features. And after I can relate the features, uh, I can combine them. Okay. Does anyone else have any question? Okay, fine. I don't think there are any more questions in the chat section. So I'll come to this part. So again, this part is very important. So I'll spend some time on it. So what are the tips for future machine learning competitions? Okay. So first tip for all the newcomers or the people who have, just participated in their first machine learning competition or second machine learning competition. Uh, so the first tip is reusability, right? So say if I write some piece of code in a earlier machine learning competition, I'll not write the same piece of code for this competition too, right? So you must know how to save your code in a proper and structured way so that you can use it for future competitions. So that will save a lot of time and obviously save from errors that you can cause when you write your uh, same code again and again, right? So first step for future machine learning competitions is reusability. So you must keep your codes reusable. Okay. Uh, Second part is simplicity. So I would like to focus on simplicity a lot. So I'll share my competition code after this too. So if you see my competition code, okay, just give me a second. I'll show you my screen. Okay, yeah. I hope you guys can see my code. Just a second. Yeah. So if yeah, I hope you guys can see my code. So if you see my code is very short itself, right? So my code is not very long. And after creating uh, say so many features, 300 around 330 features, uh, the length of my code is very short and it's very manageable, right? So I've divided my code into different sections. So say in this part of the code, I'm dealing with interaction swipes, or say in this part of the code, I'm dealing with age, or say in this part of the code, I'm dealing with the skills of the different users, right? So simplicity is very important in the sense that, okay, yeah. So simplicity is very important in the sense that if you keep your code simple, you can do rapid experiments. And when you can do rapid experiments, that means you can try out a lot of things in machine learning competitions, right? So basically, say if a machine learning competition is for 7 days. So in 7 days, you would want to try a lot of different things rather than sticking to one thing and trying the same thing again and again. So for this, if you keep your code simple, uh, you can experiment with it and get better results. Now talking about the speed of the code, right? So another factor in machine learning competitions is to write a code that can run fast. So again, it's related to the previous thing of what I had told you. So if your code is fast enough, you can do more experiments, and if you can do more experiments, your probability of doing well in the competition increases, right? So if you can do more experiments, you can find out more ways to improve your score, and obviously improving your score will help you at the end, right? So how do you write a code that's actually fast, that you will gain by experience in participating in say different machine learning competitions. So if your code is usable, that will surely help you with the speed part too, right? Now, time. So how do you manage your time in machine learning competitions, or say which part of the uh, which phase should you spend your most time on, right? So just going back to this part, which part should you spend most time on? So I hardly spend say 5% of my time in the first two phases, right? So I hardly spend 5 to 10% of my time in understanding the problem and understanding the data. So you should not spend too much of your time in understanding the problem as well as understanding the data. Then again, building a solution, analyzing the data can be done fairly quickly. So creating good features, I would like to highlight this. So this is the phase where you should spend most of your time on, right? So uh, anyone who wins a competition is the person who has created the best features, right? So I won this competition because I was able to create really good features. So I was able to create really good features because I had the time uh, to spend to create really good features, right? So most of your time I feel should be spent on creating good features. So people talk about say things such as feature selection and uh, other different things in which data cleaning and other phases in which you should spend your time on. But I believe that most of your time in a machine learning competition should be spent on creating good features, right? Yeah. So yes. Yeah. So again, selecting final submission. So selecting final submission machine learning competitions is tricky. So since you guys have participated in machine learning competitions, you might know that machine learning competitions are divided into two phases. The leaderboard part, right? So one is the public score and the other one is the private score. So to get a good private score as well, you should be careful in selecting your final submission. So in that case, my tip would be to select a submission that has a really good validation score rather than a really good a public leaderboard score. So yeah, if you see this part, my public score is say 86.86, and if you see this part again, my private score is 87.02. So for me, both the public score and the private score were good because I had a good validation strategy, and then obviously it was my summation that had the best validation score, right? So again, this part is a kind of a tip for people who are new to machine learning competitions, is that you should choose submissions with uh, good validation scores. Okay. Okay. So yes. Okay. We have some more questions in the chat section, so I'll try to answer them. Okay. Someone had asked, so basically you use ensembles, but can you tell which models are suitable for this kind of problem? So if you see this problem, this is a more of a structured kind of problem, right? So you're not working with image data or say NLP data directly, right? So we had embedding matrices, but we are not working with NLP data directly. So in this case, in most of the competitions I find in structured data competitions, gradient boosting models work the best, right? So that's why my final winning solution also had contained a model called light GPM, right? So for these kinds of problems, gradient boosting models will work the best. Okay. I'll share the link to my code. I'll share the link to my code later on. Okay. I have to make it public. Okay. Fine. Does anyone have any more questions? If so, you can type it in the chat section.
Just to remind everyone that we have 10 minutes left. If you guys have any questions to Nikhil, feel free to ask in the chat. So also, Nikhil, you mentioned a time that you spent, like time is very important as well. Can you share with us how much time did you spend for building solution?
Yes. So yeah, one thing in machine learning competitions is that you have to be regular, right? So you cannot, start a competition, then leave it midway, and then uh, in the final 2 or 3 days expect you to do some kind of magic. So every day, or say, or every 2 to 3 days, I used to spend at least 1 hour in this competition. And actually, there was some time where I was not able to improve my score. So I guess for around 14 to 20 days, I was not able to improve my score at all. So I was stuck at that point of time. but then again, I found some new ideas, and with those new ideas, I was, gradually able to improve my score. But yes, as you mentioned, time is very important. So you need to invest time, and for investing time, you need to understand which phase of the machine learning competition should I be investing my time on to get the best results.
Cool, thank you. Looks like you have a lot of questions in the chat.
Sure. So I tried to answer. Yes. Yeah. So Michael has a very interesting question that should be answered. Okay. So when you are iterating, do you try GVM models with higher learning rate to run faster initially, or do you start with low learning rate? So basically, firstly, I try to make my models to run as fast as possible. So say if I'm talking about, say, a k-fold validation. So in that case, I will not run all the k different models. I'll run only one model, and I'll probably run it with a higher learning rate so that I can experiment rapidly. So, the ensembling part or running different models or hyperparameter tuning running with lower learning rates, this is the part I reserve for the end of the competition, right? So maybe in the last week or so, I can focus on that part. So the major portion of the competition should be spent on rapid experimenting. So yeah. Okay, can you show the slide that translated competition goals and your session goals? I'm not sure which slide are you talking on. Yeah, so competition goals was already shared by Jorge, so I'm not talking about it again. Okay. Okay, so someone has a question. So as you are a working individual, how do you find time to participate in competitions, and how much time this competition consume? So yeah, uh, it's participating in competitions is a kind of a hobby for me, right? So whenever I find free time, I try to spend that time in participating in competitions, because when you participate in competitions, you are working on a new problem, and you're working on a new problem, you learn something new, right? So that's the kind of investment for your future. So that's about it. Okay, yeah. So when do you use deep learning? So again, you could have used deep learning in this competition too, but as I said earlier, this is more of a structured database competition, right? So when you have structured data, most of the times you'll see that solutions such as gradient boosting will work much better than deep learning. So that's why I did not use deep learning in this competition. But for unstructured data problems such as image data or natural language data, in that case, you should be using deep learning. Okay. Okay. So Niranjan has a question. So, okay. So the percentage of times in the steps. Okay. So I'll modify the slides and then I'll share it. No issues. Okay. So yeah. So the higher learning rate to lower rate I was talking about, I was telling that, say, if you run a model with high learning rate, the model will converge faster, right? So if you're running a model with high learning rate, you can run a same model in say 10 minutes instead of 60 minutes. So if you can run a model in 10 minutes and get the results quickly, you can again, try something different with the model and see how the model improves. Things that will definitely improve the model, you can obviously keep those things at the end, not focus on those things at the beginning, right? So decreasing the learning rate or tuning the hyperparameters, these kinds of things I keep for the end. Okay, so do you guys have any more questions?
Guys, we have 5 minutes left. Feel free to type questions to Nihil. Yeah, thank you for explanation, Nihil. You're thanked for explaining it very clearly.
Yeah, thank you, Niranjan. Okay, so Yuntai has a question about the size of the data set. Okay, so I'll just check the size of the data set. I don't remember it now, but I think I have it opened on my notebook. So I think the size of the data set should be available here. Okay. Yeah. So as you can see, there are around 9 lakh rows in the training set. So I'm not sure about the test size as of now, but there are around 9 lakh rows in the training set. And the data set size was huge. It's because the number, you know, the feature creation scope was large, right? So this is the just the number of samples that we had. But if you multiply this with 330, we're getting a lot of different elements here, right? So I'm sure that many of the competitors have created more than 330 features. Some might have even created up to 1,000 features. So I think we had around 7 to 8 different data sets that we could actually work on and create the features from that, right? So that's why I was telling that the data set size is quite large. Okay. Okay, fine. So we have some more questions. I'll try to answer them now. Okay. Okay. Yeah. Okay. So someone has a question. Did you manually tune hyperparameters for grid search it? Okay. So again, hyperparameter tuning is something I keep for the end, right? And I don't spend time on tuning the hyperparameters. And as for this competition, I tuned it manually. So as I told you, tuning hyperparameters will not give you that much of an improvement compared to feature creation part, right? So I would say most of your time should be spent on feature creation part, not on things like hyperparameter tuning or ensembling, right? Okay. So someone has a question. Do you have a criteria for choosing which competitions to join? So I feel whichever competition I can win, I join the competition. And yeah, apart from that, any competition which is new and I can learn from it, I definitely join. So as such, no other criteria. Okay, yeah. So Michael has a question. So how do you do feature selection? Do you rely on light GBM feature importances, or do you use trial and error or something else? So there are actually a lot of different ways in which feature selection can be done. And I don't rely on only one thing. So yeah, light GVM's features importance is actually very helpful in feature selection and even feature generation, right? So if, when you do feature importances and you see that these are my top 3 features, right? So in for this competition, say if age was my top feature, I saw that age is my top feature. So next time when I'm iterating and creating more features, I can use age in combination with other features to create more and more features, right? So again, there are a lot of different techniques for feature selection, right? So I don't rely on only one technique. Okay. Yeah. So Collab Pro is not available outside US anymore. I think Collab Pro is available uh, uh, in all regions. We just have to enter a US zip code, right? So I think Collab Pro can be used by anyone, right? So you can definitely use it. Do we have any more questions? I think we have only 1 minute left, I guess.
Yeah, if you guys have the last question, we will accept only one. Okay, people thanking you, Nihil, for amazing talk.
Thank you, everyone. Thank you, Bedgreet, and obviously LeWagon for giving me this opportunity. Yeah.
Cool. And it's almost 8 p.m. In Japan, and it's time for us to wrap up this event today. Thank you so much, Nihil. I see people are already waiting for the code from you, and obviously they're waiting for you for the presentation to share. If there is any way, if you want to be connected to people, feel free to leave any contacts. If of course you want people to connect to you.
Sure. I'll leave my LinkedIn. Don't worry.
By the way, how do data scientists usually connect with each other? What is the most popular like networking tool for data scientists? Is it LinkedIn or any other thing?
For me, I think it's LinkedIn. So I've connected to most of the people I know on LinkedIn itself. And many people I've collaborated with, I've connected with them on LinkedIn. So yeah, definitely LinkedIn.
Is there a way for data scientists to share their portfolio in a nice and efficient way on LinkedIn? How do you usually show your value to like potential partners or maybe employers?
You know, there are a lot of fields in LinkedIn, which you can update. So, right. So, what are your achievements? See any summary about you, or see any different links or any projects you have worked on. So, I usually try to keep it updated. And obviously, if you talk about portfolio, GitHub is the best place to do that, right? So, if you can add your features on features, your projects, and everything you've done on GitHub, and attach a link on LinkedIn itself, it will be really helpful for your potential employees and people who want to connect with you.
And obviously, can we find you on Yenta? The user is asking if you're using the matchmaking app.
Yes, I have, logged into Yenta, but I think that uses some kind of distance-based algorithms. You'll only find people near you, right? So I'm not sure if many people are near me right now. So obviously, I have an account on Yenta for sure.
Thank you so much, Nikhil. And well, probably you could share your LinkedIn in the chat. I will give a microphone to Yuria. I believe that she wanted to share their news about their new competition coming on Being Great.
Thanks, Sasha. I think I already shared the slide for the new competition actuary, so I might going to share it later. But I also shared the competition link as well as the new article it just came up. So you guys can probably just check there. If you haven't actually signed up on bitgrid.net, please do, and let us know if there's any other questions.
Cool. Thank you so much, guys. Thank you so much, Yuria. Thank you so much, Nikhil and Jorge. I hope that was very inspiring talk for many of you guys. For those who are already in the competition world, that was really good to know the approaches, the winning solutions, and those who just started learning data science and who just want to try the data science competitions as a way to polish skills or kickstart the career. Also, I hope that was a very valuable resource for you guys. Once again, thank you so much for staying with us until that late. We really appreciate it. And probably on this note, I will wrap up this event. Once again, for those who are interested in events from LeWagon and BitGrid, feel free to follow our meetup channels. And thank you so much one more time. Have a great evening for those who are in Japan, and have a great evening for those who are in the India zone, I believe. I'm not sure how much time you guys know right now.
Yes, it's around 4:30 p.m.
Okay. Have a great upcoming evening. Thank you so much, guys. I will wrap up this event. Bye.
Thank you, everyone. Bye-bye.
Thank you. Bye.